Hi guys, welcome to another Tuesday Tune. My name's Steve, I run Vorsprung Suspension up here in Whistler. And this week I wanted to talk to you a little bit about durability, specifically for rear shocks. So those of you who have followed our channel closely and our social media, I suppose, are probably fairly familiar with a significant amount of what I'm about to say. This is something that may ruffle a few feathers. If you're a frame designer, you are either going to love me or hate me for some of my comments here. What I'm going to talk about is in particular the way that shocks are integrated with the frame. This is mostly to do with the different types of mounts that we have to connect your rear shock to your frame. Some of these are unequivocally better than others in terms of durability. There are significant compromises that frame designers have to make and many considerations that they have. Durability is one of those, it's not all of those. In my eyes, obviously, as someone who works in the field that I do, durability is very important. And all too often I feel it is overlooked and somewhat sacrificed for a couple of reasons. One of the reasons, probably the biggest one, is packaging. We have to fit the shock to the bike in a place that works around everything else. And if you look at all the different rear suspension designs out there, you'll see there are endless ways to mount the shock to the bike. There are many positions. You'll see shocks anywhere from right in front of the rear wheel, down low behind the bottom bracket, running up inside the frame on some of the bold frames, connected with yokes, trunnion mounts, located in any orientation you can imagine, vertically, horizontally, diagonally, upside down, sideways, like literally sideways. Pretty much everything has been tried at some point. So let's have a dig into the common mounting types and what they might mean for the durability of your shock. This is something I feel like is not frequently discussed in public, partly because the people who really have the weight to make some kind of impact on this are typically the shock manufacturers, right? So they're the people who manufacture the shocks and they want to say, hey, look, put our stuff on your frame, sell your bike with our suspension. They're not going to go to a frame manufacturer and be like, hey, your frame design is destroying our shocks. However, there are many cases where this is true. Sometimes this is big brands, sometimes it's little brands, sometimes it's one particular model of bike, sometimes it's design issues, sometimes it's manufacturing issues. Sometimes it's just bad luck. I want to make it fairly clear here as well. I'm not actually criticizing shock manufacturers who manufacture shocks that have to interface with certain mounting standards. If you're a shock manufacturer, you're going to make things to fit the frames that exist and the requirements that you have. You're going to do the best that you can to make shock that lasts in those environments with those mounting systems under the loads that it's going to see. With that said, some shocks are more durable than others, but in this case, I'm not actually particularly interested in trying to blame shock manufacturers because a lot of the difficulties that we see are not actually directly the cause of the shock. The failures will occur at the shock, but they're not necessarily caused by the shock. See what I'm saying? In the same way that if I throw a rock through the windscreen of your car, your windscreen was the point of failure, but it wasn't the cause of the failure. Anyway, let's have a dig into the common mount types and what they do, how they work, what their effects are. So let's look at a traditional eyelet, right? So we've got a Cane Creek shock here, Kitsuma, it's the current model. This is a standard plain bearing eyelet, right? So that means plain bearing is also known as bushing. In this case, it's a plastic polymer IGUS bushing, similar to what Fox uses as well. Other alternatives of that type would be like a DU bushing or a DP4 bushing. So these are the traditional bushings that we used for quite a long time. These are fairly good. They have some advantages and some disadvantages. One of the advantages is that they're cheap, they're light, they are able to deal with immense loads. Disadvantages were typically to do with wear. Anyone that's ever had a bike that just ate DU bushes knows what I mean. They have some advantages in terms of rigidity, or the lack of, which I'll discuss in a bit. A common alternative to a DU bush or an IGUS bushing in the end there, like a plain bearing, is a trunnion mount like this. Maybe you can see it a bit better this way. This is used to shorten the effective eye-to-eye of the shock. When the metric shock standards were introduced about 5 years ago, eye-to-eye lengths of shocks grew relative to their stroke. This was considered a big advantage at the time because you could have more overlap inside the shock, and that would mean that the thing was much better at dealing with side loads. It gave shock manufacturers more space to fit things inside. In general, it was a pretty good move. The longer eye-to-eye did have some disadvantages though. It makes it harder to fit the shock in the frame, particularly with size small frames, particularly if the shock is mounted vertically and you have clearance issues underneath the top tube. This is where trunnion comes in. It makes the shock shorter. It also will use a pair of sealed cartridge bearings on the mount there, so you get no friction there, which is very good, right? The disadvantage of the trunnion mount compared to standard DU bush like that, if you look at it, it's much wider, all right? So the width alone is not the specific problem. The problem is the rigidity. Let's take a look at why that is. So here we've got a standard eyelet, plain bearing or bushing in the eyelet there, and a 1/2 inch piece of hardware. So this was the de facto standard for quite a long time. What you'll notice here is that if I push sideways on that, this has a certain amount of flex in it at the eyelet. All right? You can see that moving sideways there. And that means that it's able to tolerate, like I'm not pushing very hard on that, I'm using one finger. It's able to tolerate a certain amount of misalignment of the frame. And that misalignment can happen as a result of manufacturing, just misalignment of the parts as they're assembled, or flex of the frame under load. So that might mean when you're cornering hard, you're pulling the rocker arm one way or the other. The shock is actually fairly able to deal with those side loads just by not being too rigid. Now let's have a look at a trunnion shock by comparison. So this trunnion mount, 54 millimeters wide instead of 12.7. Not sure what that is in furlongs. So this, by comparison, is basically dead rigid. That means even the slightest amount of misalignment between the eyelets, whether that again be due to manufacturing concerns or due to side load on the frame, like flex under cornering, the shock simply doesn't have a way to be able to move and take that up. So taking that capacity for misalignment further would be spherical bearings. I don't have an example on hand to show you here, but a spherical bearing is a bearing that will allow the hardware to basically rotate freely any direction at either end. And the advantage of that, it keeps the force acting directly between the eyelets, because any side loading can simply rotate the thing to where it needs to be. The spherical bearings will just allow that misalignment without any resistance. And that means that you can only actually have force acting directly along the axis of the shock. Greatly reduces side loading, reduces wear, reduces ingress of dirt and contaminants at the seals because there's less misalignment in there. It's much easier on the shock. There are, of course, advantages and disadvantages to everything, right? Spherical bearings are fairly expensive. They're a bit of a pain to replace when they wear out. They are a bit heavier than these alternatives. Typically, they require bigger eyelets, so you need more clearance around there. It eats into the space, the design space of the shock and so forth. So nothing is perfect, right? Everything has some compromise. There are also some other examples. This is a frame-specific example from a Santa Cruz shock, or a Santa Cruz spec shock. This uses a pair of cartridge bearings in the end. This end here is in the lower link of a VPP bike. It allows for movement with very little friction, which is good. The bearings themselves actually have a tiny bit of play, and this is a 30 millimeter wide piece as compared to a 54 millimeter wide trunnion. So it's still quite a bit less rigid. At the other end here on this particular shock, we have a standard plain bushing. So again, it allows for a certain amount of misalignment. And these ones seem to not be anywhere near as hard on shocks as the trunnion mounts. Now, what could we do to a shock to put even more load on it if we were really trying? Well, one way would be to turn that eyelet sideways and extend this out another 100 mil or 150 mil. That's exactly what a clevis or yoke mount does. So you'll often see these yoke extenders that split and go around the seat tube here. They do that so that they can fit the shock in a place that it otherwise wouldn't be able to fit or wouldn't be able to reach. Some frames I've seen even have a combination of a yoke mount at one end to lengthen the shock and a trunnion at the other to shorten it. If you're a frame designer, can you please stop doing that? Now, does that mean that having trunnion or a clevis mount on your bike makes it a piece of shit? Of course not. It does, in some circumstances, accelerate the wear on your shock. It can shorten the service intervals. It can make the thing basically less durable than that shock would otherwise be. If it was that big of a deal that every single shock was failing and exploding in the first 5 seconds of riding, the manufacturers would have worked it out. like frame manufacturers, they don't want their bike to be associated with destroying shocks and being essentially an unreliable bike as a whole. There are other further complications. As e-bikes have become more and more prevalent, we've lost a lot of the clearance around the bottom bracket that we would typically have. That has meant that there is more demand for shorter shocks with a given stroke, especially if you want to fit a water bottle in. You don't want to just fire the shock horizontally at the middle of the down tube. And as a result, trunnion mounts have become almost inevitable on a lot of e-bikes. With that said, I am strongly of the belief, and if you work at Fox or RockShox, feel free to correct me if I'm wrong. I am strongly of the belief that basically the shock manufacturers are not giving frame manufacturers much pushback on designs that kill their shocks, simply because the frame manufacturers in this case are the customer. If you go to your customer and be like, hey, you're an idiot, you're designing something that's destroying our shock, stop doing it, they're going to say, no, your shock is failing, we're going to buy from your competitor because we don't like you. This is an unfortunate reality of pretty much all customer-vendor relationships. Having worked in the automotive industry previously, I've seen many examples of the exact same thing happening with car manufacturers who make terrible design decisions. They push that back on the OEMs, so the original equipment manufacturers who are making the parts for them, and make it their problem. I think the same thing is happening with shocks, quite frankly. Anyway, no doubt I've pretty much eliminated any industry rate deals I was ever going to get on frames here, but it is food for thought. Again, it doesn't automatically mean that the frame that you own is a piece of crap or that your shock is going to blow up tomorrow, anything like that. They are accelerated wear concerns. Some of them are bigger deals than others. The longer the yoke gets, the bigger of a deal it is. If you got a yoke that extends your shock out by 20 mil, 50 mil, it's not that big of a deal. Some of the ones that I've seen that are 150 mil, well, now you've almost doubled the length of the shock. If you've ever looked at Euler's buckling equations, you'll see that that actually increases the propensity of the shock to buckle and try and bend itself in half by the third power of the length. That means if you make the thing twice as long, it has 8 times the propensity to buckle. That's a lot more side load on your shock, a lot more wear, a lot more problems. As a general rule, from a shock design point of view, we want to avoid that. Again, there's many competing requirements when you're designing a frame. You have to make it light, you have to make it look good, you have to fit everything in, you have to have a water bottle, the shock has to not punch through your e-bike motor, and so forth. There are a lot of considerations. And so, very easy for me to sit here and say, hey, you're doing it wrong. I don't actually have to deal with the compromises that the frame designers do. One of the real difficulties with criticizing things like this as well, right? So from my point of view, I can't give you test data because there is none. One of the difficulties when it comes to assessing misalignment is you don't know how much you have, right? You have a frame might have a manufacturing tolerance, but that doesn't necessarily tell you what kind of alignment the shock is going to face in reality. You can put a shock on a dyno with a specified amount of misalignment and run it through however many cycles you want. But actually replicating real-world riding conditions for different types of mounts, it's pretty difficult to do. As someone who's run a structural test lab in the past, if you don't have a specific standard to test to, it's almost impossible to be confident that your product is actually sufficient for its needs. If you're going to try and test a shock for its side load resistance, for example, its misalignment tolerance, or even the length of a yoke that you can put on it before it starts seeing particularly accelerated wear or premature failure, you need to have very well defined conditions for that. Right? And so putting a yoke on something and running it up and down on a dyno that only loads it vertically and doesn't have any of the rotational or inertial components, like when a bike is bouncing around, in reality the weight of the shock is pushing it up and down, among other things, and any friction or binding in the pivots also contributes to that loading. When you bench test something like that on a linear dyno, you don't get any of those effects. It's very hard to quantify and say, well, actually, we can be sure that our shock works with up to 100 mil clevis extender. You can try, you can come up with your own tests. As far as I'm aware, there are no ISO tests or anything equivalent to that that would indicate how durable something should be or what sort of tests it should pass in order to be considered sufficiently durable for use in that application. It would be good if we're going to continue with using trunnion and clevis mounts, and realistically we are, me ranting on the internet is not going to change anything here. If we're going to continue using those, I think the industry needs to come up with some kind of real world verified and validated bench test standards. So standard amounts of misalignment, standard side loads applied through the shock, and so forth, to actually be able to go to a frame manufacturer and be like, yes, our shock has been okayed for use on your frame. It's been approved, we've tested it, we know it's okay. Your frame also needs to meet the other side of these criteria, where it is tested to have, under cornering loads, for example, under a specified cornering load, it has less than a certain amount of deflection at the shock mounts. Your shock mounts need to have an alignment tolerance of X millimeters, 1 millimeter plus minus from top to bottom, or whatever it may be. I'm not going to name names. I've heard many horror stories from both sides of the industry here. And it seems that the lack of a consistent testing standard is leading to us developing and adopting these standards that offer one big advantage, like trunnion is a great example, shorter shocks, bearings that don't flog out like a DU bushing does, but have a significant disadvantage anecdotally, from our experience, in terms of durability of the shocks that use it. So if you work for a company big enough to be doing it, can I propose that you develop a test standard? Contact ISO, make it an ISO standard, give everybody something that they can actually test their shocks to and say, yes, this is sufficiently robust to withstand this particular application. Also, your frame has to be sufficiently stiff enough that when we load it in the ways that we know we're going to see in reality, that we are not exceeding the misalignment of the frame that we know the shock has been tested to. Until we get to that point, we're going to continue seeing failures that involve a lot of finger pointing, like I'm doing right now. Anyway, I hope that slightly bit of rant has provided you with some kind of insight as to what the different mount options for shocks are and some of their respective advantages and disadvantages. Till next time, we'll see you then.